1.4 absolute value inequalities. Our goal is to solve and graph them, then write the solutions in interval notation. So, absolute value inequalities work the same way as regular inequalities. You'll need to set up two problems. When you set up the second problem, make sure to switch the inequality symbol around. Now there's a typo here. This should say -5. Sorry. So why do we switch the symbol? Because, remember, whenever we multiply or divide by a negative number, we switch the symbol. So when we turn this 5 into a -5, that is why we switch the symbol. So now we're going to add 3 to both sides. And we get x is less than 8. Or add 2 to both sides. X is greater than -3. Sorry, there's one more typo. This should be the word and. So just a little hint. If we have the absolute value of something less than a positive number, it's going to be an and statement. And if we have something in here greater than a positive number, and remember these have to be positive numbers, otherwise we can't do it, it's going to be an or statement. And you need to know that because the graphs are different. And you're going to see that here. When we graph this, greater than -3 is going this way. And less than 8 is going this way. So we're looking for the values that satisfy both. In which case, it's between -3 and 8. And then in interval notation, sorry, the parentheses, not a bracket. Like so. So here we go. The absolute value is already by itself. This is a positive number. We're good to go. X plus 3.5 is less than or equal to 15.7. You just copy it the way it is. You also set it up this way. X plus 3.5 is greater than or equal to 15.7. Now think about, is this going to be an and or an or? Make a prediction and let's see what happens. Now I'm going to subtract 3.5 from both sides, which gives me x is less than or equal to 12.2. I'm going to subtract 3.5. And this should be negative 15.7. I think I said it, but didn't write it. Minus 3.5 cancels. X is greater than or equal to. I need to add these. So 7 plus 5 is 12. 5, 6, 7, 8, 9. 1. Negative 19.2. Well, here's negative 19.2. And here's 12.2. It's going to be a solid dot here and a solid dot here. It's greater than this one, but less than this one. So therefore, this is an and statement. And the interval notation on this bad boy is from negative 19.2 to 12.2 brackets. Okay, is the absolute value alone? No. It has to multiply by 2 and subtract 4. What do we get rid of first? Go back to basic problem solving. Because this is just a quantity that we're looking at. So it's 2 times that quantity minus 4. Now it's an absolute value, but still theoretically, what do we get rid of first? The 4. So we're going to add 4 to both sides. Which That gives me 2 times the absolute value of x minus 3 greater than 16. Then divide by 2. Absolute value of x minus 3 is greater than 8. Now, think about it. Is this going to be an and or an or statement? It's greater than. So now I'm ready to go. X minus 3 is greater than 8, just the way it's written. Then x minus 3 less than negative 8. So we switch the sign, we switch the symbol. Going to add 3 to both sides. X is greater than 11. Going to add 3 to both sides. X is less than negative 5. I wasn't paying attention. There were arrows already down here. Sorry. I just made my own. Okay, since I realize it now, my error. I'm just going to come down and do it here. So, here's my number 11. Here's negative 5. They're both open dots. It's greater than 11, less than negative 5. So the interval notation is, well, which way is the negative 5 going? Out towards negative infinity. And it's an open dot. I also have the 11 going out towards positive infinity. Open dot, parentheses, union. Okay, what do we do here? We need to get it by itself, so we're going to multiply by 2, both sides. That gives me the absolute value of 2x plus 3 less than or equal to 20. And or. Think about it. Everything's ready to go. 2x plus 3 is less than or equal to 20. 2x plus 3 is greater than or equal to negative 20. Going to subtract 3 from both sides. 2x is less than or equal to 17. Subtract 3. 2x is less than, sorry, my bad. Greater than or equal to negative 20 minus 3, negative 23. Divide by 2. Oh shoot, I must be wrong. They got a fraction. No, that's okay. Fractions are our friends. Might be easier for graphing if you want to convert this to 8.5. Probably don't want to put an equal sign for the inequality, so x is less than or equal to 2 times 8 is 16 plus 1 is 17. 8.5. And I'm going to divide by 2 here. We get x is greater than or equal to negative 23 halves. X is greater than or equal to negative 2 goes into 22 11 times, with 1 left over. 2 times 11 is 22, plus 1 is 23. Now, it's less than 8.5, less than or equal actually. It's greater than or equal to negative 11.5. Therefore, it is in between negative 11.5 and 8.5. Bracket, because it's less than equal, greater than equal. Number 4, minus 1. We need to get rid of that. X minus 2 over 3 greater than 4. Now some of you may think I need to get rid of that 3 by multiplication. Can't do it. Ask yourself, why not? If you said it's because that is inside the absolute value bars, you are correct. It's safe within there. It's part of the absolute value. So we leave it alone. Think about graph and or, what's it going to look like. Opposite directions in between. So I'm ready to go. X minus 2 divided by 3 is greater than 4. X minus 2 over 3 is less than negative 4. At this point, I can multiply by 3. 3's cancel. I'm left with x minus 2 is greater than 12. 3's cancel. X minus 2 is less than negative 12. Add 2 to both sides. Well, that gives me 14 here. Add 2 to both sides. When you add 2 to both sides, you get x is less than negative 12 plus 2 is negative 10. So, when we go to graph it, we got a negative 10, and it's an open dot, and it's less than. We have our 14, open dot, and it's greater than. Therefore, we have a union. The negative 10 is going this way towards negative infinity. The 14 is going this way towards positive infinity. They're parentheses because they're less than and greater than. We put the union symbol in between. And there you have it. There you are.